Welcome to Young Techies. My name is Soham.
My name is Sanika.
And I'm Amresh.
Hey, Mr. Techie. We can make a program that can track down any prime number.
Oh, so now you want to write a program from prime number.
Correct.
So what you're saying is you want to write a program that will tell if a given number is prime or not.
Yep.
Okay. Let's talk a bit about prime number. Do you guys know what exactly prime numbers are?
Well, prime numbers are numbers that are divisible by only itself and 1. I mean, all numbers are divisible by other numbers, but then it goes deeper in decimals or there's a remainder. Without a remainder or any decimals, it is divisible by 1 or itself.
Okay. So do you have a good example?
I think I have an example. 12 divided by 2 equals 6.
Okay.
And because it's like divisible, it cannot be prime. But if it's 13 divided by anything, like it's gonna always get into a remainder, so therefore it's not prime. But it cannot be 1 that you're dividing it by.
Okay, perfect. That's a good point. Yep.
There can be no even numbers.
Oh, the prime number are never even?
No even.
Never?
Never. Only 2 is the only even number there is in prime numbers.
Okay.
And 5, you can't have any number. There's no number that has 5 in it for prime. Only 5 itself is the only prime number that has 5 in it.
Okay, good. So essentially, let's find out a strategy, right? How do you find if a given number is prime or not? If we divide that number by 2 and we check from that number up to that number, right, with every number, and check if it is divisible by if it is divisible by that number with no remainder, will that make a trick for us?
Maybe, yeah.
Yeah. Okay. All right. So that's the problem, right? And that's how we can probably address it. Make sense?
Yes.
So let's take a look at algorithm, okay, for the prime number. So in the prime number algorithm, it is little more complicated than most of the algorithms we have done so far. You have to first take a variable to know or to find if the given number is prime or not. Second, you have to define a variable called Boolean variable. What it really means is it's more like yes or no. Third, you have to start a loop for all the numbers between the number given and the half of it. And that's where you start a loop. And for all the numbers in that range, like from 1 to that range, you're going to check if that number is divisible by any of it. And if it is, then that's how you declare it as a not prime. So you don't have to check it for all. Even if it is a single number, that says, it's divisible fully, that's not prime for sure. So that's the algorithm, okay? Alright guys, let's take a look at prime number coding and let's get it done in Swift. So as discussed in algorithm, we are going to have 2 variables. One is the check if it is a prime number. Check, let's say, check prime. And let's make it 13, the example we gave in the algorithm time. And let's define another variable, as we said, that is divisible, and let's just call it a boolean, as we talked. And let's just make it false to start with. We just have to define it something. Now let's take a for loop, as we discussed earlier, and say for count in. So at the time of video, I actually mentioned 1, but I was wrong. It's not 1, it's actually 2. And that's because, everything is divisible by 1. So it's really 2 that we are checking, and from 2 up to check if prime divided by 2. So that's the range we want to check at, okay? And then inside this for loop, we're going to say if, so this is an important simple one, check if prime percent. So percentage is an important operator here. It's more like a reminder operator, so to speak. If that is equal to count equals 0, okay? So if that happens, then make the Boolean variable is divisible equals true, because then it is divisible by something. And as discussed, we don't have to check it for everything. Even if it is a single number that is divisible by, we are going to quit this loop. So this is a very important function here. So we basically say here break. So that's a pretty crucial one. And then we move from here to the next one, which is, say, in the bottom one, if is divisible equals false, then say print. So if is divisible to false, which means it is a prime, right? So we're going to say print. If you remember our syntax, the check if prime is a prime number. Okay, and it's not if it is not, if it is true, in other words. So basically else, we're going to say print. So the exact same thing. I'm a big fan of copy paste because I'm a lazy person. Basically it's not a prime number. Okay, so that's it. That's pretty much what we need to do to test it. So let's test this one out and see what happens. Let's see. Oh my gosh, look at that. It says 13 is a prime number. Now let's just take a look at 12 and see if that is prime. Oh, 12 is not a prime number, which is accurate. Let's just do some more testing here, okay? And let's see if it is all coming along fine. 15 is not a prime number, accurate. 17 is a prime number, perfect. Now let's just test 2, okay? Just 2 and see what happens. What happened? It looks like there is an error, and what that error is it's basically saying that the count operator, you can't go from 2. So basically you're saying for count in 2 to 2 by 2, which is 1. So you can't reverse this count. Now fortunately, in this particular case, we know that the up to 3. So this issue we are going to face only up to 4, right? Only up to 3. So if it is a 3, we're going to face probably the same issue, because it's kind of 1.5. So 2 to 1.5. So it's the same problem. But as soon as it hit 4, this issue should vanish, right? So it says 4 is not a prime number. So from 4 onwards, the algorithm works fine. But for anything before 4, it doesn't work, right? And hence, what we're going to do is on the top of this conditioning, we will have to create an extra loop that says, not loop, but the if condition, where we're going to say, hey, look, if it is less than 3 or less than 4 rather, then don't even bother, just declare it that it's a prime number. Okay, so that's going to be the algorithm here. So we're going to say if, and this is it's kind of difficult to figure these things out at the algorithm stage, and that's fine, you don't have to. I mean to say if check if prime less than 4, then we are going to say so and so is a prime number, because we know that all the prime numbers before 4 actually are prime numbers. And then we're going to say else, okay, and we're going to say brackets, and then this one we're going to put it in the end to complete it accurately. Let's see if that works for us. So now let's run this for 4. Well, 4 is not a prime number, it worked. Let's run it for the lower numbers where it was not working in the past, and now it is working. So it's going to work for 3, it's going to work for 2, and let's just make sure that after we did a change, it's working for the original code or original program as well. So 13 is a prime number, 12 is not a prime number. Make sense? So this is how we're going to write a code. It's a little complex code than probably the one that we have done so far, but it's a pretty interesting one, and it should give you guys a good hands-on Thanks for watching, young techies.
If you like this video, click the like button and click the bell notification icon so you won't miss any of our videos.
And do not forget to subscribe.